Hello and welcome to this session. My name is Rohini Gaukar and we are going to talk about activities to do in your first hour on AWS. Obviously, we need to start with the creation of AWS account and accessing it. We will talk about the first steps at securing your account access, creating your first virtual server in the cloud, navigating through the billing and cost management console, implementing some initial account and resources, security best practices. By the end of this presentation, we will also provide next steps to continue your journey on AWS. The Amazon Web Services Free Tier is designed to enable you to get hands-on experience with the AWS Cloud services. The AWS Free Tier includes services with the Free Tier available for 12 months, following your AWS sign-up date, as well as additional service offers that do not automatically expire at the end of your 12-month Free Tier term. Everything we show today can be done within the free tier. For more details, follow the link on the slide. To sign up for an AWS account, please visit the link on the slide and click on Sign in to the console. This will direct you to the page for creating a new account. Please keep a credit card and a phone ready for verification. When you create an AWS account, you create an account or a root identity which you use to sign into the AWS. You can sign into AWS Management Console using this root identity, that is email address and password that you provided when creating the account. This combination of email address and password is also called as root account credentials. When you use your root account credentials, you have complete unrestricted access to all resources in your AWS account. However, we recommend you do not use root account credentials for everyday access. We especially recommend that you do not share your root account credentials with anyone, because doing so gives them the unrestricted access to your account. It is not possible to restrict that permissions that are granted to the root account. You should use IAM to create and manage user identity and permissions to provide secure and limited access to your AWS resources, both for yourself and for others who need to work with AWS resources. For increased security, we recommend that you configure Multifactor Authentication, also known as MFA, to help protect your AWS resources. MFA adds extra security because it requires users to enter a unique authentication code from an approved authentication device or SMS text messages when they access AWS website or services. You can enable virtual or hardware MFA device for both your root account and IAM users. A virtual MFA device uses a software appliance that generates a 6-digit authentication code that is compatible with the one-time password standard. You have only one MFA device assigned to a user at a time. Each MFA device assigned to a user must be unique. A user cannot enter code from other users' device to authenticate. SMS MFA is currently available only as a preview program. You can find detailed documentation on how to configure this in the AWS IAM documentation. The AWS Global Infrastructure is comprised of 42 availability zones across 16 regions worldwide, with another 3 in France, China, and Sweden coming online throughout 2017 and 2018. Each region is a separate geographic area. Each region has multiple isolated locations known as availability zones. Select a region that is closer to you and your end customers. Resources aren't replicated across regions unless you do so specifically. AWS has been continually expanding its services to support virtually any cloud workload. It now has more than 90 services that range from compute, storage, networking, databases, analytics, application services, deployment, management, developer, mobile, Internet of Things, artificial intelligence, security, and enterprise applications. Today we will quickly look at some of these services. Amazon Elastic Compute Cloud, or Amazon EC2, is a web service that provides secure, resizable compute capacity in the cloud. It reduces the time required to obtain and boot new server into minutes, allowing you to quickly scale capacity both up and down as your computing requirements change. It changes the economics of computing by allowing you to pay only for the capacity that you actually use. To use Amazon EC2, you simply select a pre-configured templated Amazon machine image to get started immediately, or create a custom AMI containing your applications, libraries, data, and associated configuration settings. Choose which instance type you want. Then start, terminate, and monitor as many instances of your AMI as needed using the web service APIs or the variety of management tools like CLIs, APIs, or SDKs. Configure security and network access on your Amazon EC2 instance. Determine whether you want to run in multiple locations, utilize static IP endpoints, or attach a persistent block storage to your instances. Pay only for the resources that you actually consume, like instance hours or data transfer. Choosing the right EC2 instance type matters. Selecting an appropriate instance type for your workload can save you time and money. AWS has a wide variety of EC2 compute instance types to choose from. Each instance type or family like T2, M3, C4, C3, G2, R3, etc. is optimized for different workloads or use cases. There are families optimized for general purpose, burst performance, compute, memory, GPU, storage, and I/O. Within an EC2 family, you can choose from different sizes. For example, micro, small, medium, large, extra large, and 2 extra large. AWS uses Intel Xeon processors for the EC2 instances to provide customers with high performance and value for their computing needs. When you choose your instance type, you should consider the several different attributes of each family, such as number of cores, the amount of memory, amount and type of storage, the network performance, and processor technologies. Another important consideration is the total cost of ownership. A lowest price per hour instance is not necessarily a money saver. A larger compute instance can sometimes save both money and time. It is important to evaluate all the options to see what is the best for your workload. AWS launched C4 compute optimized instances which utilize Intel's latest 22nm Haswell microarchitecture. C4 instances use custom Intel Xeon V3 processors designed and built especially for AWS. Through its relationship with Intel, AWS provides its customers with the latest and greatest Intel Xeon processors that help in delivering the highest level of processor performance in Amazon EC2. Intel Xeon processors have several other important technology features that can be leveraged by Amazon EC2. Intel AVX is perfect for highly parallel HPC workloads such as life sciences or financial analysis. Intel AES NI accelerates encryption, decryption of data, and therefore reduces the performance penalty that usually comes with encryption. Intel Turbo Boost technology automatically gives you more computing power when your workloads are not fully utilizing all CPU cores. Think of it as automatic overclocking when you have thermal headroom. The matrix on the slide highlights the individual Intel technologies that were discussed previously, and then the EC2 family that can leverage each of these technologies. For more information, please refer to the link on the slide. Each vCPU is a hyperthread of an Intel Xeon core for M4, C4, R3, R4, G2, I2, and D2. Amazon EC2 lets you choose from a number of different instance types to meet your computing needs. Each instance provides a predictable amount of dedicated compute capacity and is charged per instance hour consumed. General purpose instances provide a balanced set of resources suited for a wide variety of applications. High memory instances offer large memory sizes for high throughput applications including databases and memory caching applications. High CPU instances have proportionally more CPU resources than memory and are well suited for compute intensive applications. There are also various high storage and cluster compute instances available. For more information, please refer the link on the slide. Amazon Elastic Block Store or Amazon EBS provides a persistent block storage volumes for use with Amazon EC2 instances. EBS volumes are availability zone specific. Each EBS volume is automatically replicated within its availability zone to protect you from component failure, offering high availability and durability. EBS encryption provides seamless support for data at rest and data at transit between EC2 instances and EBS volumes. You can protect your data by creating point-in-time snapshots of EBS volumes which are backed up to Amazon S3 for long-term durability. There are different types of EBS volumes. The general purpose SSD volume balances price performance with a wide variety of transactional workloads. Provisioned IOPS SSD volumes are highest performance SSD volume designed for latency sensitive transactional workloads. Throughput optimized hard disk volumes are low cost HDD volumes designed for frequently accessed throughput intensive workloads. Cold HDD volumes are lowest cost HDD volume designed for less frequently accessed workloads. In the demo, we will create the general purpose SSD volumes. So let's see a quick demo that will focus on launching and connecting to EC2 instances, attaching EBS volumes and creating an image, Amazon machine image. Once you log in using the AWS IAM user credentials, you will land into the AWS Management Console home. At any time, you can use the top toolbar to perform functions like reaching this console home or to navigate to each of the AWS services individual dashboard, or use it to access the account and billing dashboard, and also choose any of the AWS region for creating your resources. For this demo, we will be selecting the Singapore region, and from the services menu, we will select EC2 under the compute category. Click on it. This will take you to the EC2 Service Dashboard. In the EC2 Service Dashboard, you can find summary of provisioned resources, a launch instance button, a navigation pane that takes you into each page for more details, your account attributes, and the AWS-wide Service Health Dashboard. Now let's launch an EC2 instance by clicking on the blue Launch Instance button. This will run you through a wizard to select from a wide variety of pre-configured Amazon machine images and the required steps to launch this EC2 instance. Let's select an AMI from the community AMIs. For Amazon Linux operating system released in March 2017. Click Select. The next step is to select the instance type from a wide variety of instance types that we previously discussed. For this demo, we will use the T2.micro instance as it is eligible for free tier. Click Next to configure the instance details. Start with creating one instance within its default virtual private cloud. A VPC is a logical isolation of network in AWS. The default VPC has default subnets in each availability zone. For now, leave other parameters as default. You can also add user data to bootstrap the instance under the advanced details. Now let's add storage. By default, the AMI has 8 GB root unencrypted EBS volume of type GP2. You can add more volumes at this stage if required. moving on to adding tags. Tags are key value pairs that help you organize and identify your launched EC2 instances. Step 6 is to configure a security group. You can either create a new one or reuse existing security group. Let's create a new security group and name it Innovate Demo SG and give it a proper description. Then add rules for inbound traffic. You can select a pre-configured or any of the custom rules. Then modify the port numbers or range and specify the source IP address range, or another security group that can access the instance. To access the instance over SSH and RDP, it is strongly recommended to allow only specific IP addresses that are known to you. And finally, review the details and click Launch. The wizard will ask you to select the key pair you want to use to connect to your instances securely. To create a new key pair, give it a name and click on the Download Key Pair button and store it securely. Once done, click on Launch Instances. Instance creation will be initiated. Let's go back to the dashboard and view our instances. The instance is hosted in AZP, has a unique instance ID, and is currently in pending state. You can find more information about the instances in the tabs below for description, the automated EC2 status check, the monitoring graphs provided by CloudWatch for default metrics like CPU, network in, network out, disk read and write, and burst credits, etc. And finally, the Tags tab to add or edit new tags. Let's go back to the Description tab. The instance currently has a private IP from the default VPC's subnet range. Once the instance's state changes into running, the instance will receive a public IP and DNS. The status check will be initialized as the instance boots. If you ever find that the checks do not reflect your actual experience, please do not hesitate to submit feedback. While the instance is still booting up, let's move on and create and add an EBS volume. Click on Volumes in the navigation pane. In the Volumes page, click on Create Volume button. In the dialog box, from the different EBS volume types, select volume type as General Purpose SSD. Then edit the volume size to be 1 GB. For availability zone, select the value as AP Southeast 1B as our instance is in that availability zone. And click Create. Refresh the page if you do not see the newly created volume. The volume is now available to be attached to an instance. From Actions, select Attach Volume. In the dialog box, select the instance and the device location. Once finished, click on Attach. The volume should now be attached to the EC2 instance. Now let's move on to connecting to the EC2 instance. Select the instance and click the Connect button. This will give you basic steps depending on the instance's operating system. First step is to change the permissions on key pair file that was downloaded. And then use the SSH command to connect to the instance. As I'm on Mac, I'm using the inbuilt terminal instead of PuTTY for connection. Let's get some latest updates on this instance. Once done, we will also be looking at the disks attached to this instance. Great, our volume is attached but not mounted. Follow the detailed steps in documentation to mount the attached volume to this instance. And finally, let's see how to back up this instance into a customized AMI. Go back to the Instances page, select the instance, and Then click on Actions button to start, stop, or terminate it, and also to perform any additional steps for this instance. To create AMI, under Image, click on Create Image option. In the dialog box, give the image a name and a proper description. By default, EC2 shuts down the instance and takes snapshots of any attached volumes, creates and registers the AMI, and then reboots the instance. Choose No Reboot checkbox if you don't want your instance to be shut down. Modify additional volume details if required and click on Create Image. While your AMI is being created, you can choose AMIs in the navigation pane to view its status. Initially, it will be in pending. After a few minutes, the status should change to available. Choose Snapshots in the navigation pane to view the snapshot that was created. When you launch an instance from this AMI, we use these snapshots to create new volumes for the new instance. So you can select also to recreate the individual volumes from the snapshots. You can see the references of the snapshots in the AMI's block device mapping. Now that we have seen how to create your first EC2 instance, let me introduce you to another compute service on Amazon Web Services. Amazon LightSail is the easiest way to get started with AWS for developers, small businesses, students, and other users who need a simple virtual private server, or also known as a VPS solution. It includes everything you need to launch your project quickly: a virtual machine, a SSD-based storage, data transfer, DNS management, and a static IP, all for a low, predictable monthly price. LightSail offers a range of operating systems and application templates that are automatically installed when you create a new LightSail instance. The application templates include WordPress, Drupal, Joomla, Magento, Redmine, LampStack, Nginx Stack, a mean stack, a Node.js stack, and more. You can install additional software on your instances by using the in-browser SSH or your own SSH client. After logging in to LightSail, you can use the LightSail console, CLI, or API to create and manage instances. The first time you log into the LightSail console, choose Create Instance. The Create Instance page is where you can choose the software, the location, and the name of your instance. Once you choose Create, your new instance will spin up automatically within minutes. It will perform all the required steps for creating infra, adding security configuration, and installing application all under the hood. LightSail plans are billed on an on-demand hourly rate, so you pay only for what you use. For every LightSail plan you use, we charge you the fixed hourly price up to the maximum monthly plan cost. The cheapest LightSail plan starts at $0.0067 per hour, which is about $5 a month. These prices are region specific, so do check out the prices in your preferred region. Data transfer in to LightSail instances is always free. Data transfer out from a LightSail instance to another LightSail instance or AWS resource is also free, while the private IP address of the instance is used. You will only get charged for the data transfer out from LightSail instance to the internet or to AWS resources over public IP address, if you exceed your plan's monthly free data transfer allowance. Whether you're an existing or a new customer, you get 750 hours of free usage of the $5 LightSail plan for free. You can use 750 hours of usage across as many instances as you like. The free trial offer is only applicable to usage within the first calendar month when you sign up to use LightSail. LightSail is best suited to projects that require a few virtual private servers and users who prefer a simple management interface. Common use cases for LightSail include running websites, web application, blog, e-commerce sites, simple software, and more. If you want to set up a multi-tier applications, large websites that are resource intensive, then host them on EC2. They provide full control of the underlying infrastructure to suit your performance needs. This should give you a brief idea of navigating the console and launching your first compute resources on the AWS platform. Now let's understand features in the billing and cost management console. You can choose to have AWS publish billing reports to an Amazon Simple Storage Service or an S3 bucket. You can choose to receive reports that break down your costs by the hour or month, by product or product's resources, or by tags that you define yourself. The Cost Explorer is a no-cost tool for viewing your AWS cost data as a graph. You can use the Budgets feature to track your AWS cost. Budgets use the cost visualization provided by Cost Explorer to show you the status of your budgets, to provide forecast of your estimated costs. You can also use budgets to create CloudWatch alarms that notify you when you go over your budgeted amounts or when your estimated costs exceeds your budgets. The AWS platform is designed to accommodate every size of company, from small startups to enterprises. If your company is large or is likely to grow, you might want to set up multiple AWS accounts that reflects your company's structure using the consolidated billing features. These are some of the security practices you should enable when you create a new account. Enable AWS CloudTrail to track user activity and API usage. Enable AWS Config to have a graphical audit of your resources. Whenever you are assigning permission, grant least privileges to account and resources. Follow the documentation for the AWS IAM best practices. And finally, create Amazon VPCs for your different applications and environments and grant least privileges. So the next steps: find more information at these links for AWS white papers and AWS documentation for services and getting started guides. Also, do sign up for AWS support and AWS blog. Finally, I would like to thank you for attending this session and sticking it out until the very end of the presentation. I also wanted to wish you good luck in getting started on AWS. If after today you are wanting to take your AWS knowledge to the next level, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy and operate highly available, cost-effective, secure applications on AWS. And finally, don't forget to validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. For more information, please refer the link on the slide. Thank you.